Okay, so everybody did pretty well here. So let's, first of all, replace these variables by actual numbers. And let's say we've got 22 grams on day 5 and 9 grams on day 11. Okay, again, this is the familiar radioactive decay. You know, it's exponential. So let's just say, okay, I stated it, but I didn't write it. We've got some radioactive stuff. Okay, now it's more complicated if we got like 2 radioactive elements. And we're not going to deal with that at all in this course, okay? But we're going to implicitly assume we have 1 radioactive substance that decays at an exponential rate. Okay, so first thing. Radioactive decay implies exponential decay. Implies I'll use y and t as my variables. Okay, most everything we're using y equals a e to the kt, and that's one form. Okay. You can also use, in some of you did, a equals b to the t, totally equivalent. Or even y equals a times 2 to the kt. This is a perfectly valid form. And in some cases, if you're trying to deal with half-lives and so forth, that third one is actually the preferred form. It's also a transformation of our basic exponential function, okay? So we should understand this function pretty well. Anyhow, I'm going to do it in at least 2 of these ways, just to show you that we get the same model either way. So, first thing we do, I'm going to use the AB to the T form. This is actually the one that you can solve without using logarithms. And you know how to use logarithms, so it's okay. You can solve either of these using logarithms, it's equally easy. But I'm going to use the AB to the T form. I'm going to assume y equals AB to the T. And one thing I'd like to see, looking at your homework, you know, which for the most part came out pretty well, still people miss things that they probably wouldn't have missed if they'd have sketched a graph. So I'm going to sketch a graph with my information on it. Here's y. Here's t. It doesn't have to be a great graph, although you want to kind of scale it reasonably. So we have day 5 through day 11. So I'm going to put 16 days on my graph. So here's 8, here's 12, here's 4. And then we have individual days in there. And on my y, I go up to 22 grams. So I'm going to extend my y-axis a little beyond what I originally had it. And put 32 here. Power 2, it's easy to subdivide. And if this is 32, this is 16, this is 24, this is 8. So I can kind of see where to put my points. On day 5, which would be here, I've got 22 grams, which is right between 20 and 24. Doesn't take long to slop down a graph. And then 9 grams on day 11. Day 11 would be right here, and 9 grams would be here. So 9 grams, day 11, it's here. And now you draw an exponential curve. If you've drawn a lot of exponential curves, and a lot of you apparently have, because you're drawing pretty good looking exponential curves, you see that this thing's going to have a shape that kind of makes this like this. If that's a good curve, then I estimate that my y-intercept might be around 35, 40, somewhere around there, okay? So if I solve my equations and get something that isn't consistent with the picture that I have here, by not consistent, I mean not necessarily exactly the same, it's not going to be exactly the same. But if I get a model that isn't roughly represented by this curve, then I know that I did something wrong. Either the curve's wrong or the model's wrong. Okay. On the test, I could well ask you, graph this data, graph this information. Okay. Graph the information, now solve the model, now tell me what the half-life is. Okay. This is, I think, a really important part of what you need to do, because you lock in the picture in ways that you don't lock in the algebra. Now, many of you are pretty good with your algebra, so you might lock in the algebra too. That's even better. And some people are much better at locking in algebra than they are at locking in pictures, but still you want both. Now, those people are just, I don't understand. I know they exist. There are people in graduate school who could do anything but not understand any of what it means. And that may, I mean, you could be a good research mathematician. Do that. Okay, anyhow. And a digression. We make this assumption, we draw this picture. Then we write our simultaneous equations. Put our information into that form, which almost everybody did, either with this form or this form. Okay, that's going to be y stands. Well, if you put the stuff on a graph, you got to keep it straight. This point is 522. This point is 11.9. If we take 522, so I'm just going to say that point 522. This information here tells you that 22 equals a b to the fifth. And your 11.9 point, which corresponds to 9 grams a day 11, tells you that 9 equals a b to the 11. Because again, this is y, this is t. You plug this in for y, you plug this in for t, you get this equation. So you plug this in for y, this is y, you plug this in for t. Now, how do you solve this equation? Well, you know, we talked last time about solving some linear equations. You're going to have at your next assignment. Solving some linear equations in 2 dimensions. We solve those by elimination, because that's going to lead into the matrix methods and we kind of end up the course methods. Okay? We can't solve these by elimination. There's no multiple of this we can add to this to eliminate A or B. So what do? Well, we use the other method. We're compelled to use this method Solve the first equation for A. Get 22 over B to the fifth. Yeah, read that. It says plug into the second equation. They plug into the second equation, you get 9 equals 22 over B to the fifth times B to the 11th. Well, from this, you get 22 B to the 6th equals 9. That's pretty obvious. B to the 11th divided by B to the 5th. You got 11 B's multiplied up above, 5 B's multiplied below. You group 5 of these with these 5, and dividing each other gives you 1, and you're left with 6. You want to have that picture. Okay, so anyhow, you get 22, or you can memorize the rules of exponents and realize you got to subtract 5 from 11. It's important to know that that's the rule. It's important to have that in your head, but you got to remember why it is, or you start getting confused in the rules. So make sure you understand the rules. Okay, this gives us B to the 6th. Equals 9 over 22. Raise both sides to the 1/6, or if you prefer, take the 6th root of both sides. Select. Multiply the exponents, you get B to the 1. Equals 9 over 22 to the 1/6, and that's about 0.4. If you take the 6th power out, you get 0.9, we give you a little less than 0.9, I'd say about 0.88. That could be far off, but I kind of think I'm close. Okay. Well, then we plug that in up here and we evaluate A, or we plug it in here because this is equivalent to this equation. I don't have a lot of room, so I'm going to kind of okay. 0.2 over 0.88 to the 5th. 0.88 to the 6th is around 0.4. That's going to be 1.45, 22. I'm getting a ridiculous result. Never mind. I don't know about the 44, between 40 and 50. So let's just say we get 44. Okay. So now our model is $44, that's your A. times 0.88 to the t. That's b to the t. My point is, given this information, you can find the model. And given the model now, I can ask you, what's the half-life? I can ask you how much stuff you have after 60 days. Answer. Okay, well, let's go ahead and do it briefly, since we've talked about all this. So how much after 60 days? Well, you get y equals 44 times 0.88 to the 60th. Okay. I'm guessing that you get around 1/5000th of what you have here. I'm guessing maybe around 0.01. Okay. Somewhere in that order. That's what you get. And it's not going to be very high. Okay. So plug it into your calculator. Once you have your model, there's nothing to it. Okay. How long until 3 grams? Well, the amount is 3. Y stands for the number of grams. Three equals 44 times 0.88 to the t. Point 88 to the t is 44 thirds. T is log base 88 of 44 thirds. Which is a log of 44 thirds divided by the log of 0.88. Remember, in this course, no fair using your log base b key, which would never even be there. Okay. In other words, when you work it out, I want to see this before I see an equal sign and a number. Okay. If you get the number using the log base b, okay. I can't tell. But if you don't have this step there, I assume you use that log base b, and I'm going to ding your score a little bit. Fair enough? Well, if you totally understand why, I want you to understand the algebra. You say that's fair enough. If not, you say, well, that's not fair, but I have to do it. Okay. Believe me, there's a reason for it. Might be inconvenient, but there's a reason for it. Okay. Well, what about the half-life? Well, y equals 44, t equals 0, so y equals 22 after a half-life. You understand what half-life is? It's when you get half. We're using T half for the half-life. That means 22 is going to equal 44 times 0.88 to the T half. Because after a half-life, starting at T equals 0, T is going to be T half. See, solve this equation. And the solution is very easy to write out. Log of 0.55 over the log of 0.88. And I'm going to guess that equals approximately 4. Should be between 4 and 5 if I've got my numbers straight. Okay. So again, with a calculator, you're going to get a more precise answer for the growth factor. Okay, well, what if I ask for the growth factor, growth rate? Growth factor is 0.88. Every time T changes by 1, you get 0.88 or 88% of what you had before. Means every day you end up with about 88% of what you had the day before. Growth factor or growth rate is negative 0.12. There's a formula for that, but all this is saying is every day you lose 12%. If every day you end up with 88% of what you had the day before, should be pretty obvious that every day you're losing 12%, right? That's the meaning of growth rate and growth factor. There's pretty much the whole picture of exponential functions as far as this course is concerned. Now, another question I could easily ask, what's the average rate of change between day 6 and day 14? Well, you know how to do an average rate of change. And if you don't, well, review it, okay? Because I'm not going to take the time to do this. We do want to do some simultaneous equations. Okay. Now we're going to go ahead and do it. See if I get a little more board here. We're going to do it with the AE to the KT model and see that we get the same thing. And we'll see what that K is, what the meaning of that is. Okay. Well, we've pretty much solved most of the stuff that we can do. Most of the stuff you need to know about exponential functions. Or this form. Now this form's totally equivalent. We'll talk a little bit about how and why it's equivalent. Let's first get the model. Okay, so obviously the model y equals ae to the kt. Well, you get the equations. (22) equals ae to the 5k, so, right? So go ahead and solve these actual equations, just to make sure you're totally focused on this. I'll give you a few minutes and then we'll run through the solution. I'll give you my approximation and see how close my approximation is to my previous solution. Okay. Now, you really need to know what to do with this equation, and some of you are having a little trouble with that, okay? So let's make sure we understand we've got two unknowns in this equation. That's A and K. He's not unknown. No, there are two equations we can solve for A and K. Not linear. We can't use elimination. We can use the method of solving either A or K by eliminating the other variable, right? So we eliminate one variable. How do you eliminate one variable? You solve for that variable, and then plug that solution into the other equation. You pick one equation and solve for your variable, plug it into the other equation. Exactly what I did here. Okay, I have my A, B to the T. I got my two equations. And I solved the first equation for A. I plugged that solution in for A in my second equation. Here's the solution. Here it is plugged in to the second equation. And then the solution's straightforward. Once you do that, you just do the algebra. Okay. But those two steps are critical. So make sure you understand them because we've done this a number of times. Review a little bit if you have to. Of course, your text does it. You might want to look at that. My lab or open math does it. Okay, so anyhow, eliminate the one variable. Okay, from the first equation, we solve for A. Okay. Second equation is 9 equals A e to the 11k. So, well, we have a value for A. We plug it in here, and all of a sudden our equation is not going to have any A's in it. Replace A by 22 over e to the 5k, and now the only variable is k. And we have something that's easy to solve if we remember the rules for x and so forth. That gives us the equation. (22 over e to the 5k multiplied by e to the 11k). Now, how do we solve that equation? Well, let me ask you to write down this equation and solve it if you haven't already. Some of you have. But focus on this one idea, that the first step in solving these equations is really straightforward. You're going to solve for one of the variables, and you're probably not going to solve for k because you'd have to use logs. It could be done. It would be a bad exercise just to stretch yourself a little bit. You probably don't have time insufficient just to be able to solve for A. And then plug it in, and you get this equation, and you'll see that this is an easy equation to solve. If you rules for exponents and so forth are, so let's just write it out again. We got 9 equals 22 over e to the 5k times e to the 11k. Very possible. How do we solve for k? Okay. Now, here's the equation. We want to solve this equation for k. Well, this becomes equals 22 e to the 6k. By your rules for exponents and rearrange fractions and so forth, we're going to be dividing this by this. We'll do e to the 11k over e to the 5k. Well, we actually go ahead and write this out a little more explicitly to make sure that we see why it's e to the 6k. Everybody eventually got that. But this is e to the 11k minus 5k by rules for exponents. Okay. So that 9 equals 22e to the 6k. Well, now this is a logarithmic equation. I mean, an exponential equation. We're going to convert it to logarithm because a is in the exponent. Convert to the logarithmic form, but we're not yet ready to convert this to the logarithmic form. Convert, remember we have b to the a equals c is equivalent to log base b of c equals a by the inverse function definition of the log. So we've always got to keep this in mind when we're dealing with an exponential or logarithmic equation. if your variable is in the log, you're going to convert to exponential. And then your variable, if your variable is part of C, now it's out here where you can operate on it. Okay. If your variable is part of A, well, you convert it to this form and now you can deal with it. Okay. Okay, so we convert the log form, but first, you got to have it in the form B to the A equals C so you can do the conversion. Well, why is this not in the form B to the A equals C? Well, here's your B, that's E in this case. And here's your A. But you got not just B to the A on this side, you got that 22 in front of it. You got to get rid of that 22. Okay, so you get e to the 6k is 9 over 22. Now we've done this. It's been a week or a little more. So you got to kind of refresh your memory on what you did well. Because again, you keep coming in well prepared, doing good work. Okay? You got to put it together. And you got to remember what you did earlier. And when you're doing it, you got to do it in such a way they're going to remember, or at least going to remember having done it. Okay? And y'all are making good progress in that. You know, your results have been good so far, and I expect them to continue to be good. Okay, so we have e to the 6k is 9 over 22. We convert that to log form. Get log base e of 9 over 22 equals 6k. Well, there's our k. All we got to do to solve for k is divide 6 by log base e of 9 over 22. Log base e is a button on your calculator. We don't even have to do log of 9/22 divided by log of e. Okay, we just do natural log. So we put this in the form 6 over natural log of 9/22. We put that in our calculator. And you get k is approximately negative 0.15. For some reason, that's not. Oh, man, what did I do? I thought it was weird getting that log in the denominator. I checked that the numbers just didn't match. That was not going to work, not even remotely. Okay. Now that works because I'm kind of checking that out in my head, saying log base e is 9 over 22. 9 over 22 is pretty close to the reciprocal of e. Reciprocal of e is about 0.37, and that's about 0.4. Okay, so I know that that has to be pretty close to -1. -1 divided by 6 would be -1.17. So anyhow, there's our value of k. Again, every step of this is something that you've done well. Okay, just make sure you know how to put the steps together in the context of solving a problem this time. Now, I use an A up here, but the A up here is not the A in this equation. We understand that's just the form that I usually write the equivalence between log and exponential form. Okay, so, go back to here. A is 22 over e to the 5k. Okay, well, e to the 5k, k is negative 0.15, so it's e to the 5 times negative 0.15. That's approximately equal to 46. Now remember back a month ago, when we closed this problem and I drew this graph. I'm sure it seems like a month. Okay, look at this graph. Does this graph reasonably have a y-intercept in the 40s? Or is it consistent with a graph with a y-intercept in the 40s? Well, that y-intercept looks more like it's about 36 when it ought to be 46. That's just because the curve is a little steeper and at this point might be a little too far to the left. Graph gets pretty steep up there. It's a little hard to accurately approximate where something that steep intersects that vertical line. No excuse, I could have drawn it better, but I didn't try. Okay, and if I'd have tried and done that badly, I'd have been really embarrassed. That's why I didn't try. Okay, well, anyhow, you get the idea. I've got a graph here. This works. This is reasonably consistent with my graph, considering how difficult it is to really estimate where two nearly vertical lines intersect. Okay. And I've come full circle. So now I have a complete understanding, at least at the level you want to have it in this course, of how to model an exponential function and what kind of questions you can answer. We've answered about every question you can answer. Okay, well, last thing is, this model gives us the same solution for A as this model did. I said approximately 44. It's closer than I even deserved to be, but reasonably close. It turns out it's 46. If you do the numbers on this thing, you do get 46 points out. Okay. Well, now we got two models. I'll use 46 instead of 44 with my 0.88 to the T. -46 e to the negative 0.15 T. Why should these be the same? Or nearly the same, reasonably, up to the approximations. Well, let's just look at 46 e to the negative 0.15 T. Your rules for exponents tell you that e to the negative 0.15 is just e to the negative 0.15 T is just e to the negative 1.5 raised to the T power. Well, what's e to the negative 0.15? You've got your calculator. think it'll be around 0.86 or something like that. What'd you get? No, don't say it, don't say it. Okay, I said I thought that'd come out around 0.86 because I was thinking of the Taylor expansion of the exponential function, which tells you that for small values of your exponent, the exponential function is approximately equal to 1 plus that exponent. Well, 1 plus a negative 0.15 is 0.85. Now, there's another term, a quadratic term on that thing, and you don't know what I'm talking about, but that raised it a little bit. So I just guessed, okay, I'm going to raise it about 0.1. Okay, so I was actually using something that's a second semester calculus topic. And I just mentioned it so you're motivated to learn as much calculus as you can. So you can do miraculous things like accurate estimates. Well, that came out much more accurate than I had any reason to. This though is approximately 46 times 0.86 to it. Now, that compares with this. Remember that I got that 0.88, not by calculating anything, except some calculations in my head. And I kind of got too high in that. There's a big difference between raising 0.86 to the 6th power and raising 0.88 to the 6th power. So I kind of screwed that up a little bit. I should have been close to that. Still, this being a mental estimate and this being what it really is, if you work this out accurately, you are going to get a 0.86. Tells me that my growth rate is only 0.86 instead of 0.88. That's growth factor. So you're actually losing 14% every day instead of 12%. Okay. So I recommend two things as an exercise to help you pull this all together. It's not required. If you do the steps, I'm very happy. Got to use an e to the negative kt. Do a times 2 to the negative kt. Yeah, just do the whole thing over. Only takes a few minutes to do it once you understand the process. And if you take the few minutes it would take to do this, while this is still somewhat fresh in your mind, it'll lock it in much better. Okay. I know you have restricted time, but you know, the holiday coming up, I don't know if you're going to have time to do that, but if you do, I think it'd be good for you. And then you can kind of do what I did here. You're going to get a different value of K. Different K. And 2 to the K. Still going to be like 0.86. In the form 2 to the negative. That's true. In this form, it's especially easy to find the half-life. This goes to half when the exponent's -1. So when KT equals -1, there's your half-life. Okay, now you do have homework on solving a system of 2 equations and 2 variables. It should be an easy assignment. We did a little bit of that last time. Okay. It's just be able to do it by elimination. You can also do it by substitution. It's an algebra 1 topic. I don't think you're going to have any trouble with it if you follow the videos, and you might not even need the videos if you remember what we did in class. Okay. Should not be a difficult assignment. Take a little time to review this so it'll pull together for you when you come up to the final, because you'd expect things like this on the final. Okay.